This is going to be the last part of chapter 5, so we'll be doing some definite integral examples involving natural log and exponential. All right, so we'll be doing these 3 problems, and then that'll be it for this chapter. Now, number 1. Well, the first thing I'll do is factor out the 5 in front of the integral. So I have it as 1 divided by some quantity, and so by one of the integrals that we've learned in the past in the previous videos was 1 over u du is equal to the ln of absolute value plus c. So it has that structure. U is going to be 3x plus 1. So derivative du, derivative of 3x plus 1 is 3, because it'll be 3 times 1 plus 0, so 3. And then I got to attach the dx. And in the integral, I have just dx, so I need to multiply by a third. So I have 1/3 du equal to dx. Okay, so that I can substitute in for dx, and then this is what I'll sub in for u. Now, since it's a definite integral, I need to change my limits of integration. So for the limits of integration, our lower limit's 0, so if x is 0, u is 3 times 0 plus 1. So u is going to be 1. And if x is 4, u is 3 times 4 plus 1, so 13. So we have 1 and 13 are our new limits of integration. All right, so making these substitutions, so we still have the 5 in front of the integral, so we 5 times our new bounds, 0 changed to 1, and then 4 changed to 13. Then I have 1 over u, because 3x plus 1 is u, and then dx is 1/3 du. All right, so then I'll factor out the 1/3, and then I'll have 5 times a third, 5/3. So I have that 1 over u du, so then I just change that into the natural log of the absolute value of u. So it's going to be 5/3 times the natural log of the absolute value of u. And this is a definite integral, so I'm going to put this in brackets, and then our lower bound is 1, upper bound is 13. I'm going to go ahead and factor out the 5/3, and then just keep it as the natural log of absolute value of u. And then I just apply the fundamental theorem of calculus. So it's going to be 5/3 times the natural log of 13 minus the natural log of 1. All right, that's my f of b minus f of a, or f of 13 minus f of 1, fundamental theorem. The natural log of 1 is 0, so that goes away, and I just have 5/3 times the natural log of 13. I'm going to drop the absolute value because 13 is positive. So this is 5/3 times the natural log, and I'll just use parentheses instead. Okay, so that's going to be the answer. All right, the next two examples have e involved, so I'm going to use the exponential integral. So let's see, so number 2, 0 to 1, negative 2x dx. Well, integral of e to the u du is equal to e to the u. Now, this case, u is negative 2x. So du is negative 2 dx. And then I multiply both sides by negative 1/2. So you have negative 1/2 du equal to dx. All right, so then I'll plug in negative 1/2 du in for dx, and then I'll plug u in for negative 2x. And it's a definite integral, so I got to change my limits of integration. All right, when x is 0, u is negative 2 times 0, which is 0. And then when x is 1, you get negative 2 times 1, which is negative 2. All right, so plugging these in, our integral changes. So when x was 0, our lower limit is also 0. So we're going to have 0 again for the lower limit. Now when x is 1, we get negative 2 for u. So I need to put negative 2 in the corresponding spot at the top of the integral like it is for 1. It corresponds to that. I wouldn't do it negative 2 to 0. All right, so here we listed in the corresponding order in what you see in the integral. All right, then I have e to the negative 2x. That's going to be e to the u. And then instead of dx, that's negative 1/2 du. All right, now I integrate this. So I'm going to factor out the negative 1/2. And then integrating e to the u just becomes itself, e to the u. So I have negative 1/2 and then e to the u. And then my limits are 0 to negative 2. All right, so I'll factor out the negative 1/2 and then apply the fundamental theorem. So I do e to the negative 2 minus e to the 0. All right, that's our f of b minus f of a. Well, this is negative 1/2 times, and e to the negative 2 is 1 over e squared. And e to the 0, if you do e to the 0, any number raised to the 0 power is 1. So that's going to be minus 1. And this is technically the answer. So we could have the answer written like this. Or if you want it to make the 1/2 positive, so you could bring the negative inside. So it'd be 1/2 times, and then you switch the order, 1 minus 1 over e squared. That's equivalent. Or just distributing it, you'd have negative 1 over 2e squared, and then plus 1/2. So that would be 1/2 minus 1 over 2e squared. right, so either one of those is how the answer is going to be. All right, the next one's similar. So this will be the last example. Okay, so again, we have an exponential. So we're going to do e to the u. The u integrates into e to the u plus c. In this case, our exponent's negative x squared. So u is negative x squared. Now du is negative 2x dx. So in the integral, I have x dx. So I need to multiply both sides by negative 1/2. So negative 1/2 du equal to x dx. Okay, so that's what I'll use for u, and this is what I use for du. Then I got to change the limits of integration. So the first one is 0. So when x is 0, u is going to be 0 because it's negative 0 squared. And then when x is 1, that's u is equal to negative and then 1 squared. So the negative sign's outside of the parentheses, so it is going to be negative 1. All right, so that's my new limits. So we had 0 when x was 0, u was 0. When x is 1, u is negative 1. So I put the negative 1 up top in the corresponding spot where x was being 1. So again, I don't put it as negative 1 on the bottom. All right, then it's going to be, so we have e to the negative x squared, that's e to the u. And the x dx is negative 1/2 du. All right, so I just integrate this. I don't know why I put that. All right. So this will be negative 1/2 e to the u. And then my limits are 0 and negative 1. I'm going to factor out the negative 1/2 and then apply the fundamental theorem. So it'll be e to the negative 1 minus e to the 0. That's going to be negative 1/2 times 1 over e minus 1, because e to the 0 is 1. So that's the answer. Or you could put it as 1/2 times 1 minus 1 over e. Or just 1/2 minus 1 over 2e. All right, and that's it for this chapter. We're done with the course. I might or might not make a video on the final exam review. If you go on Blackboard, there's a final exam review problems, and that gives you a lot of practice. The final exam is not going to be as many problems, but I would work out those problems for practice, and the solutions are also on Blackboard.